Let us talk about analysis of variance, also called ANOVA. It is a statistical method used to determine if there are significant differences between the mean of three or more groups. In the context of linear regression, ANOVA can be used to assess the overall fit of the model. So it comprises of three parts. The first is the regression sum of squares or explained sum of squares. So it measures the amount of variation in the dependent variable that is explained by the independent variables in this model. It reflects the improvement in predicting yi using the regression model as opposed to simply using the mean. A large SSR suggests a better fitting model. The second part of ANOVA is the error sum of squares or the residual sum of squares. It measures the unexplained variability, that is the difference between the observed values and the predicted values by the model. It represents the error or residual variation not captured by the model. It is given by this expression. And the third is the total sum of squares or the SST. It measures the total variability that is observed in the data, which is the combination of these two. It quantifies how much the observed value of dependent variables differ from the overall mean of the dependent variable. So basically, this is the sum of these two. And why do we need these two values? So basically, these will be used for calculating the F statistics. So in order to calculate the F statistics, we can follow this expression F is equal to MSR by MSE, where MSR is equal to SSE by n minus 2 and MSR is equal to SSR. So what is the F statistic and why is it important? So basically the F statistic is a value you get from running the ANOVA or regression analysis to find out if the mean between the two populations are significantly different. It is essentially a ratio of two variances, as you can see here over here, comparing the variance explained by the model to the variance left unexplained. The purpose of F statistics is to test whether the overall regression model is a good fit for the data, and it's useful in analyzing the null hypothesis. The null hypothesis states that all regression coefficients are equal to 0, meaning the independent variables do not explain any variation in the dependent variable. Now let's run the code. So this is the usual code which we have followed till now. We are importing the libraries, importing the data, assigning the values to the variable, splitting the data set, performing the OLS, and then here we are printing the summary of the model. Okay, so basically if we call this summary2 from this strength underscore LRM, we will get this following table. So when we run this, you will get the F statistics value over here. Okay, so if you want to obtain these two values also, you can obtain using this expression. You already have the value train and test which you have splitted. You can use those to obtain the values of those two You can obtain the SST and SSE, and you can obtain the SSR by subtracting the SST from SSE. So what's the significance of F statistics? So basically, if you have a higher F statistics value, it suggests that model explains a significant amount of variance in the dependent variable. This means that we are rejecting the null hypothesis, while a lower F statistics values indicate that the model does not explain much variance and the prediction might not be significant. So our aim should be to have a higher statistics value so that null hypothesis can be rejected and we get a pretty decent amount of variance in the model.